All right, today we're diving into something pretty wild in the world of AI. It's a groundbreaking method called Introspection of Thought, or INOT for short. And the core idea is exactly what it sounds like, teaching an AI how to find the best answer by, well, arguing with itself.
I mean, really think about that for a second. What if, instead of that endless back and forth you have with an AI, it could just run the entire debate inside its own head, all in a single shot, to come up with a better, more logical answer on its own? That's the revolutionary idea we're going to unpack.
So, to really get why this is such a huge deal, we first got to look at how things are done right now. How do we usually get AI to do any kind of complex thinking? Turns out, the standard method is basically a really long and very expensive conversation.
Yeah, this old way of doing things is called external dialogue, and you know the drill, right? You give the AI a prompt, it gives you an answer, you say, not quite, and you refine your prompt, and you go back and forth until you finally land on what you need. It's this constant cycle of prompting and tweaking.
And this external chat comes in a couple of main flavors. You've got chain of thought, which is kind of like coaching one AI to think out loud, step by step. Or there are more advanced setups like iteration of thought, where you literally have multiple AIs debating each other. But here's the key. In both cases, the entire dialogue is happening outside the AI's main process.
So what's the big downside to all this chit-chat? Well, it's the cost. Every single one of those back and forth steps, every question, every answer, burns through computational resources. We measure this in tokens, which you can think of as the currency for AI processing. And when you're tackling a really tough problem, that token cost just goes through the roof, making these methods super slow and incredibly expensive.
And that's exactly where this new approach comes in. Instead of just trying to make that external conversation a little bit better, researchers decided to ask a completely different question. What if we could teach the AI to have the entire debate all by itself, internally?
And the answer to that question is introspection of thought, INOT. And honestly, this completely changes the game. It takes that whole messy process of debate, criticism, and self-correction and moves it all inside the AI. It basically turns that external conversation into a self-contained internal monologue. And the best part? It all happens in one single, super efficient step.
This quote from the research paper just nails the philosophical shift here. The AI is no longer just a passive conversation partner. It becomes a self-reflecting agent. The power to challenge its own logic, to deny its own first instinct, is now baked right into its process.
So, how on earth do they pull this off? It's a really clever combination of three things. First, they use a rigid XML structure for all the instructions. This makes sure everything is crystal clear, no room for misunderstanding. Second, they use a cool hybrid language called prompt code, which mixes the sharp logic of Python with the flexibility of natural language. And third, and this is the magic trick, the code creates two virtual agents inside the model. Let's call them Agent A and Agent B, and their whole job is to debate each other. And this internal debate isn't a free-for-all. It follows a very strict cycle. First, both agents present their case. Then, they poke holes in each other's logic. After that, they each get a chance to respond with the rebuttal. And finally, they both adjust their thinking based on the debate until they converge on a single, unified answer. And remember, all of this happens automatically inside the AI in one go.
Okay, so the theory is fantastic, but does it actually perform better in the real world? This is the showdown. We're pitting IoT against the old methods, and we're looking at two key things: performance and cost.
And the very first result is just staggering. On average, INOT uses 58.3% fewer tokens than the best of the old methods. Let me just say that again. That's less than half the computational cost. This isn't just a small step up, it's a giant leap in efficiency.
This table really puts it all in perspective. On a really complex coding test, the old external dialogue methods burn through almost 85,000 tokens. INOT, on the other hand, it achieved the highest performance score, and it did it using only about 26,000 tokens. Better results for a fraction of the cost? That's the dream, right? And these performance gains are consistent everywhere you look. For code generation, which is notoriously difficult, INOT scores a 95.9, easily beating the best baseline, which couldn't get past 90.6. It's the same story when we look at complex mathematical reasoning. On a super challenging math dataset, INOT comes out on top once again, scoring significantly higher than its closest competitor.
And finally, for complex question answering,
Where the AI has to piece together clues from different sources, INOT shows a huge advantage, scoring almost 6 points higher. So the data is just undeniable. INOT is not only way cheaper, it's also more accurate.
But the power of this internal reflection idea doesn't stop with text and code. The researchers decided to push it even further and see if it could reason about images, too. It turns out the framework is incredibly versatile. They taught it to analyze visual information systematically. Start with the simple stuff like shapes and colors, then move on to advanced cues like lighting and context. It's applying that same internal debate logic to figure out what it's seeing. And the results? They speak for themselves. This approach boasted accuracy by an average of 6% on some really difficult image-based tests. This is huge because it proves that the core idea of a structured internal debate is a powerful tool for all kinds of AI reasoning, not just text.
So, when you put this all together, what does it mean? Well, this isn't just a slight improvement on an old method. We are talking about a fundamentally new way to think about building intelligent machines.
What we've seen here is a massive paradigm shift. We're moving away from that costly, multi-step conversational model of AI reasoning, and we're shifting towards a far more efficient, single-step, self-contained model of internal reflection. And this is why it matters so much. INOT gives us this rare, powerful combination. It delivers better, smarter answers at a fraction of the computational cost. This isn't just an academic win. It has the potential to unlock a whole new generation of AI agents that are smarter, more efficient, and way more autonomous.
And that leaves us with a pretty fascinating final thought to chew on. We've just seen that teaching an AI to argue with itself makes it dramatically more powerful. So, if an AI can master the art of internal reflection, what other human cognitive skills can it learn? What becomes possible when our machines can truly think for themselves?